Sections 11.1 and 11.2. We're doing a very condensed, abbreviated version of these sections. So we are going to start talking about circumference and areas of circles and parts of circles and areas of rhombuses and kites. So first things first, if you ever see in here, if it's an approximate answer or if it asks you to round, we're going to use 3.14 for pi. We're not going to use the pi button in our calculator. We're just going to type 3.14 for pi to get an approximate solution and round our answer. If the problem ever says leave an exact answer, you're going to leave your answer in terms of pi. So that means you're going to have a pi in your answer. So first things first, the circumference of a circle. There's a formula. This whole chapter is heavy on formulas, formulas, formulas. Pick the right formula based on what problem you're working with and what you're trying to find. The circumference of a circle is pi d, or the other formula is 2 pi r, where d is the diameter and r is the radius. Now remember, there's two different formulas because the diameter is 2 times as big as the radius. So again, the circumference is either pi d or 2 pi r. Based on what you have, you're going to use one of those formulas. So let's use that in our first problem. It says find the measure, round to the nearest hundredth. This says find the approximate and exact answer. So find the circumference of a circle with a radius of 11 meters. So if it's radius, I'm going to pick the radius formula. The circumference is 2 pi r. So 2 pi times the radius, which is 11. Now, since multiplication, the order doesn't matter, I can multiply the whole numbers first and say, oh, 2 times 11, that is 22 pi. So that's actually our exact answer right there. The circumference is 22 pi meters. Or if I'm going to get an approximate solution, I'm going to type in my calculator 22 times, instead of pi, I'm going to substitute that with 3.14. So anytime we're going to get a rounded decimal answer, we're going to replace pi with 3.14. And then we'll get about 69.08 meters. Make sure you put your units appropriately. If it's a normal measurement, if we're finding the length of something, it's going to be meters. If we're finding area, it's going to be meters squared. And then by the end of the chapter, when we find volume, it's going to be meters cubed. All right, find the radius of a circle with a circumference of 18 yards. Well, we know the formula is 2 pi r, so we can work that formula backwards to find the radius. So if the circumference is 2 pi r, and we know the circumference is 18, we can use that to find the radius. Now I'm going to use 3.14 to approximate. Now how would I solve for the radius? All I need to do is divide both sides by this product. And that will give me the radius. So divide both sides by that product. So that will cancel that out. And then I'll get the radius is approximately, it's just a calculator problem now, type this in your calculator, 2.9 yards. Arc length. This is different than arc measure. We found degree measures of circles earlier. Now we're actually going to find the actual length of an arc. So if you think about it, an arc is a piece of the circumference, right? An arc is a piece of the circumference. Well, here's the formula that I use. The arc length is the degree measure of the arc, which remember is the same as the central angle. So it's the degree measure divided by 360 times 2 pi r. So that's the formula to find the length of an arc. Let's use that in a problem. I want to find the length of arc AB. So the length of arc AB is going to be the degree measure of it over 360 times 2 pi r. So 360 is always going to stay the same. The 2 pi is always going to stay the same. I just need to plug in the degree measure and the radius. Now remember, we're going to use 3.14 for pi. So when we type this in our calculator, we're going to approximate and use 3.14 there. So now I just need to plug in the radius. What's the radius of this circle? That's 2. And if this central angle is 88, that means the degree measure of that is 88. So all we really needed to do was plug in here and here. So it looks like a crazy complicated formula, but most of it stays the same, 360, 2, and pi. So all we need to do is plug in the 88 degree measure and the radius, and it just becomes a calculator problem. I know it's a little tedious, but make sure you do it right. 88 divided by 360 times 2 times 3.14 times 2, and you get arc AB is approximately 3.1 meters. So the length from here to here is 3.1 meters. So in chapter 10, we found the degree measure. Now we're finding the actual length. Find the circumference of circle Z. Well, guys, this one is a little bit, let's think about this. In this formula, what is 2 pi r? That is the circumference. So in this problem, I have an arc length. Well, I can use the arc length formula. The arc length formula, that's the degree measure of the arc over 360 times 2 pi r. And 2 pi r is the circumference. So I can use this formula backwards to find the circumference. That arc length is 3.44. That degree measure is 60. So all I need to do to solve for C is multiply both sides by 360 to get rid of that 360 on the bottom, right? So multiply by 360. And then divide both sides by 60. So essentially, if this is a fraction, I'm multiplying both sides by the reciprocal. That's how you solve an equation with a fraction. If you multiply both sides by the reciprocal, that cancels that out. And you'll get the circumference after you type it in your calculator is approximately 20.64 centimeters. So we can use that arc length formula backwards to find the circumference. So again, pretty much the two formulas you need to know from this section is the circumference formula, which is either pi d or 2 pi r, and the arc length formula, which is the degree measure over 360 times the circumference, 2 pi r. Now moving on to 11.2, this is the area of the circle. This is pi r squared. This uses the radius. It does not use the diameter. So if you're given a diameter, you need to remember the relationship. The radius is half the diameter. Okay? Find the exact area, then give it to the nearest hundredth. Okay, so that means we're going to leave it in terms of pi and round. So, first one, they gave me the diameter. So before I can use pi r squared, I need to find the radius. The radius is going to be the diameter divided by 2, so 9/2, which is 4.5. So if the radius is 4.5, the area of this circle is going to be pi times r squared. Remember your order of operations. You have to square the 4.5 first. So our exact answer, if you do 4.5 squared, you get 20.25 pi. So that's our exact answer, and it's centimeters, and since we're dealing with area, our units is squared. So our exact answer is 20.25 centimeters squared. To get our approximate answer, we're going to substitute for pi. Remember, in our calculator, we're going to use 3.14 to get an approximate solution. So if you type in your calculator 20.25 times 3.14, you'll get approximately 63.59 centimeters squared. This one says find the radius. We know the area. Well, if the area equals pi r squared, Well, plug it in. We know the area, so plug it in on this part of the formula. So we can use this formula backwards. I'm going to use 3.14 to get my solution. It'll be pi r squared. Divide both sides by 3.14, you'll get 49.04 equals r squared. Well, if that's what r squared is, to find the radius, we take the square root of both sides. Take the square root of both sides, and r is going to be just about 7 feet. So just like in 11.1, we could find the circumference or find a part of the circumference, which was an arc length. We can either find the area of a circle or a part of the area, which is called a sector. So if you look at this drawing right here, I'm going to focus in on it. This shaded region is a part of the circle, and that is called a sector. This is the sector, okay? The area of a sector is found, it's a very similar formula, similar formula to the area, the arc length. It's still angle measure the arc over 360, but instead of times the circumference, it's times the area. So measure of the angle of the sector over 360 times pi r squared. So let's use that formula. I'm going to rewrite it real quick, just so we remember the area of that sector is the degree measure of the arc over 360 times pi r squared. So here we go. Find the area of the small sector. Well, the small sector is this shaded region. So the area is the degree measure, 63, over 360 times pi, 3.14, times the radius squared. It's just a formula. We're plugging it in the formula. That's all we're doing, plugging it in the formula. Degree measure over 360 times pi r squared. Okay, so make sure you have these formulas handy. So again, we're using this formula right here. The measure of that arc degree is 63 over 360 times pi, 3.14, and the radius is 5 squared. Now it's a calculator problem. Type 363 divided by 360 times 3.14 times 5 squared, which is 25. Make sure if you're using a graphing calculator, your parentheses game is strong. Make sure you put parentheses around everything. If you're using a scientific calculator, you're going to want to square this first before you do the multiplying and dividing. Okay? So you should get the area of this sector is about 13.7 units squared. They didn't give you the units. That's fine. 13.7. Now to find the large sector here, guys, is the unshaded portion. It's the part that looks like Pac-Man. Okay, so we want to find this unshaded portion. Well, we got to remember, we need to find this arc measure in order to use that formula. But hey, it's a circle. A circle is how many degrees? 360. So I could do 360 minus the arc measure that I know, 63, to find the measure of this major arc that I need to plug in the formula. And 360 minus 63 is 297. So the area will be found by doing 297 over 360, and then just complete the formula the same. Times pi, 3.14, times the radius squared, 5 squared, which is 25. So when you type it in your calculator, you can just use 25 there. And you get the area of the big one is about 64.8. Okay. Our last two formulas that we're going to learn in this section are the area of the rhombus and kite. An area of a rhombus and kite is half the product of the diagonals. So it's 1/2 of the one diagonal times the other diagonal. That's it. 1/2 of the one diagonal times the other. So, look at this. This is a rhombus because all the sides are equal. They gave me the lengths of the diagonals. So the area is 1/2 of the product of the diagonals. 1/2 of the one diagonal times the other. Nice, easy formula. Just type it in your calculator. 1/2 of 60 times 50. Or 1/2 of 50 times 60. And you get the area is 1,500. I have another rhombus. This one's a little bit trickier. They're telling you this piece here is 12. So this one's a little tricky. If this is 12, this is also going to be 12. This is 18. This is also going to be 18. So that means when I find the area here, I need to make sure I use the whole diagonal lengths. 12 and 12 would give you 24. 18 and 18 would give you 36. So now the area is half the length of the diagonals multiplied together. Type it in your calculator. Half 24 is 12. 12 times 36, 432. This one gave us units, so let's use them. It's area, so it would be meters squared. Oh, look, I have a kite. To find the area, it's half the product of the diagonals. They gave me the diagonals. That's nice and convenient. So it's half of 18 times 21. Well, half of 18 is 9, and 9 times 21 is 189. Okay? Problem D is a little tricky. So this one diagonal is 16 and 30. So the one diagonal from here to here is 46. However, they did not give me the length of this diagonal. But look, if we remember from kites, this is 90 degrees. So if I want to find this missing piece here, if that's x, this is going to be x. Look, I have a right triangle. I could use Pythagorean Theorem. Now you could use c squared equals a squared plus b squared, but this is actually one of our triples. So again, you could set up, I'm going to zoom in here, show some work. You could set up 20 squared, trying to find this piece here, equals x squared plus 16 squared. But guys, this is a 3, 4, 5 triangle. This is 5 times 4. This is 4 times 4. So this is going to be 3 times 4. That piece is going to be 12. So even if you completed the Pythagorean Theorem and you solved for x here, you would get x equals 12. So if you finished this, you would get x equals 12. So now let me rezoom in, right spot. If that's 12, this is 12, meaning the missing diagonal is going to be 12 and 12, which is 24. So the area is half the product of this diagonal, which is 12 and 12, so 24, times the other diagonal, which is 46. I'm sorry, 46. So half of 24 is 12. 12 times 46, you get the area is 552. So there's lots of formulas. If I were you, I would maybe get a spare sheet of paper or a note card and make a list of all your formulas and keep it out as you're doing all your work in this chapter. It's very formula heavy. So that way you can have a quick look at a list of things and say, oh, it's a rhombus, what's the formula? There you go. Oh, I'm trying to find a sector, what's the formula? There you go.